In this video, we want to learn how we can use special product formulas for finding the product of expressions. The first formula is a minus b times a plus b is equal to a to the 2 minus b to the 2. Probably you should be familiar with this important formula. A minus b times a plus b is a to the 2 minus b to the 2. Or sometimes we use this formula in the other way. We have these expressions sometimes and we want to factor expressions in the form of a to the 2 minus b to the 2. We can factor it this way. But in this video, we want to use this formula from left to right. We have this expression and we want to write the answer in this form. For example, if you pay attention to this first example, we have a, this first term is a, plus b times by same term a minus b. And so we can use this formula for finding this product here. By using this product, we can find the answer easily. Again, attention, this is a plus b times by a minus b. Attention, the order of the product doesn't matter. It can be a plus b first, then a minus b after. Like this example here. So here we have a plus b times a minus b. What is the answer? Always the answer is a to the 2. So the answer is 3x to the 2. 3x all to the 2 minus b to the 2. What is b? B is 5. 5 to the 2. And if we simplify this, we have 9x to the 2 minus 25. Because 3x all raises to the 2. 3 to the 2 is 9. X to the 2 is x2. So we have 9x2 minus 5 to the 2 is 25. And this is the answer. Of course, you can find the product of this binomial by this binomial by multiplying term by term. And definitely you are going to get same answer as here. But it takes more time to find the product. Let me show you how you can do it by multiplying these two binomial with the FOIL method. 3x times 3x is 9x to the 2. 3x times negative 5 is negative 15x. 5 times 3x is also 15x. 5 times negative 5 is negative 25. As you can see, these middle terms cancel each other. Negative 15x plus 15x is 0. So the final answer is 9x to the 2 minus 25. So we use these formulas for finding the products of expressions faster and easier. And I highly recommend you to memorize these formulas. Look at the next example. Radical x minus 2, radical x plus 2. As you can see here, also we have two expressions that have this format. A minus b, a plus b, radical x minus 2, radical x plus 2. As you know, when we have expressions like this, we say these expressions are conjugate of each other. What is the conjugate of radical x minus 2? Radical x plus 2. What is the conjugate of radical x plus 2? Radical x minus 2. These are conjugate of each other. And when we multiply expressions like this, we can use this identity, this formula, for finding the product of these type of expressions. So what is the answer in this case? The answer is, again, a to the 2. What is a here? Radical x to the 2 minus b to the 2. Radical x to the 2 is x, because power 2 and radical cancels. 2 to the 2 is 4. So the answer is x minus 4. Now look at these examples. Radical a minus b times by radical a plus b. Again, we can see that we can use that identity. A minus b times a plus b would be a to the 2. So the answer is radical a to the 2 minus b to the 2. What is b? B is b also here. So radical a to the 2 is a, because radical and power 2 cancels. B to the 2 is b to the 2. So the answer is a minus b to the 2. Look at the next example. Radical 9 plus h minus 3 times by radical 9 plus h plus 3. Expressions like this appears in the calculus. So it's good to learn how to multiply expressions like this. What is the answer? Again, if you pay attention, here we have a minus b times by a plus b. So the answer is a to the 2. What is a here in this example? A is radical 9 plus h to the power of 2 minus b. B is 3 to the 2. The power 2 and radical cancels. We have 9 plus h minus 3 to the 2 is 9. 9 minus 9 is 0. So only we have h. So the answer of multiplying this expression by this expression is h. As you can see, using identities, using formulas is really helpful for doing examples like this. Look at the next example. X minus 1 times x plus 1 times x to the 2 plus 1 times x to the 4 plus 1 times x to the 8 plus 1. Of course, you can start multiplying this bracket by this bracket with the normal method, then multiply the answer by the next bracket, then multiply by the next one, and finally multiply by the next bracket. But it takes so much time and it would be very complicated. And attention, when you have multiple brackets, you want to multiply them by each other, the order doesn't matter. For example, you can start multiplying these two by each other, multiplying these two by each other, and then multiply the answer of this by the answer of this, and finally multiply by the first bracket. The order of multiplication doesn't matter. But what is the best method? We want the fastest and easiest way to find the answer of this tricky question. Please pay attention. Here, if you pay attention, we have two expressions that are conjugate of each other. One of them is a minus b, the other one is a plus b. One of them is x minus 1, the other one is x plus 1. Based on their formula, based on this relation that we know, a minus b times by a plus b is a to the 2 minus b to the 2. Based on this relation, immediately we can calculate, we can evaluate this part. What is x minus 1 times x plus 1? The answer of this part is a to the 2, which in this case is x to the 2, minus b to the 2. But b is 1 and 1 to the 2 is 1, so x to the 2 minus 1. And then we have x to the 2 plus 1, x to the 4 plus 1, x to the 8 plus 1. Now, look at these two. Again, we have two expressions that are conjugate of each other. What is the answer of multiplying these two brackets? Again, by using the identity, by using the formula. The answer is a to the 2. Attention, this is a and this is b. A to the 2. What is a to the 2? x2 to the 2. So we have x2 to the 2 minus b is 1, 1 to the 2. But x2 to the 2 is x to the 4. So when we multiply this bracket here, these two brackets by each other, the answer is x to the 4 minus 1. And we have x4 plus 1 and x to the 8 plus 1. Now, what is the answer of multiplying these two brackets by each other? Try to find the answer of this part. What is the product of x4 minus 1 by x4 plus 1? The answer is x4 to the 2 minus 1 to the 2. But if we simplify this, we have x to the 8. Attention, when power raises to the power, we multiply the power. So x4 to the 2 is x to the 8. So the answer is x8 minus 1 times x8 plus 1. And finally, the answer of multiplying these two last brackets is x8 to the 2 minus 1 to the 2. But this is x to the 16 minus 1. So the answer of multiplying all of these brackets by each other is x to the 16 minus 1. Here I want to show you some applications of using the formula that we have learned for finding the product of numbers. What was the formula that we have learned? A minus b times a plus b is a to the 2 minus b to the 2. Here we want to find 1002 times by 998. 1002 is 1000 plus 2. But 998 is 1000 minus 2. So as you can see, this exactly fits with our formula. A plus b times a minus b. What is a plus b times a minus b? The answer is a to the 2. So the answer is 1000 to the 2 minus b 2 to the 2. 1000 to the 2 is 1 million minus 4. And the answer is 9999998. As you can see, we can find the answer with using the identity, with using this product formula easily. Look at the next example. You can try to find the answer of this by yourself. So you can pause the video here. After you calculated the answer, continue watching the video. 597, 603. For finding this product, attention, we can write 597 and 603 in the form of 600 minus 3 times 600 plus 3. And the answer would be 600 to the 2 minus 3 to the 2. 600 to the 2 is 3, 6, 0, 0, 0, 0. 3 to the 2 is 9. If we subtract, and the answer is 359,991. Now look at these examples. 2x plus 5 times 2x plus 5. Here, the two expressions are the same, not conjugate of each other. If we had a plus b times a minus b, we could use that formula. Here, we have to use another identity. A plus b to the power of 2 is a to the 2 plus 2ab plus b to the 2. This is the identity that we need for finding the value of this product. Attention that without this identity also you can find the answer by multiplying term by term. 2x times 5, 2x times 2x, 5 times 2x, 5 times 5, and so on. With the FOIL method basically. But it's good to know this identity. 2x plus 5 times 2x plus 5 is 2x plus 5 to the power of 2. And then by using this identity, the answer is a to the 2. A is the first term, so the answer is 2x to the 2 plus 2 times the first term, 2 times a, 2 times 2x times by b, which is 5, plus 5 to the 2. The answer is 4x to the 2. 2 times 2x is 4x. 4x times 5 is 20x. Plus 25. And this is the answer of this question. Gradually, by doing multiple examples, you should be able to write the answer of something like this immediately in this form. You should skip this middle step here. Look at the next example. In this example, we have a radical 3 minus radical 2. But the relation that we have here, the formula is for plus. If in the middle, instead of plus, we have a minus here, the formula would be the same except this middle term. So the answer is a to the 2 minus 2ab plus b to the 2. So for here, the answer is a radical 3 to the 2 minus 2 times a radical 3 times by radical 2 plus radical 2 to the power of 2. Radical 3 to the 2, radical and power cancels, we have 3. Radical 3 times radical 2 is radical 6, so we have negative 2 radical 6. Radical 2 to the 2 is 2. 3 plus 2 is 5, so we have 5 minus 2 radical 6. And this is the answer for this question. Now look at this example. X plus 1 minus radical 2x times x plus 1 plus radical 2x. If you pay attention, we have 3 terms here, 3 terms here. If you want to multiply these brackets by each other, term by term, it takes so much time because we have many terms to multiply by many terms. But if you pay attention, if we consider this as A and this as B, then in the other bracket we have A plus B. What was the answer of A minus B times A plus B? The answer was A to the 2. So the answer of this is x plus 1 to the 2 minus B to the 2. What is B? Radical 2x to the power of 2. Now, for finding this, remember the identity. A plus B to the 2 is A2, 2AB, B2. Or simply write x plus 1 times x plus 1 and multiply these two by each other term by term. But I am going to show you how we can use this relation here for finding x plus 1 to the 2. Based on this relation, x plus 1 to the 2 is x to the 2, a to the 2, x to the 2, plus 2ab, 2 times x times 1. 2 times x times 1 is 2x. And finally, b to the 2, b is 1, 1 to the 2 is 1, minus radical x to the 2 is 2x, because radical and power cancels. Now if you look here, 2x minus 2x is 0, so this cancels with this, and the final answer is x2 plus 1. So the answer of multiplying this bracket by this bracket is x to the 2 plus 1. Now look at this example. We have an expression raised to the 3, so the identity should be something like that. The identity that we need here is this identity, a plus b, like a plus b here, to the power of 3 is a3, 3a2b, 3ab2, b to the 3. So instead of multiplying this bracket by itself 3 times, simply you can use this relation for finding the answer. By using this relation, let's see what is the answer. Based on the formula, the answer is a to the 2. A is 1, so 1 to the 3 is 1. Plus 3 times a, which is 1. 1 to the 2 is 1, but let's write 1 to the 2. Times b. b is cube root of 2. Plus 3a, a is 1, times cube root of 2 to the power of 2, 3ab2, plus b to the 3. b is cube root of 2 to the power of 3. Now let's simplify. We have 1 plus 1 to the 2 is 1. 1 times 3 is 3. So we have 3 cube root of 2. Then we have 3 cube root of 4, because 2 to the power of 2 is 4. 3 cube root of 4. And finally, what is this? Cube root of 2 to the power of 3, because this 3 and this index are the same. These cancel each other, so the answer is 2. 1 plus 2 is 3, so the final answer is 3 plus 3 cube root of 2 plus 3 cube root of 4. This is the final answer for this question. Now look at these examples. In the first example, we have a binomial times by a trinomial. But we can see that we have a relation between the terms in this binomial with the terms in this trinomial. For example, here we have 2, here we have 4, and 4 reminds us 2 to the 2. X to the 2. And this middle term is exactly the product of x and 2, 2x, with a minus. For doing this example, again, you can multiply term by term and so on. But it's good to know this identity that I am going to write here. When we have a plus b times by a2 minus ab plus b to the 2, the answer is a3 plus b3. So as you can see, we have a binomial times by a trinomial. A plus b, a to the 2, b to the 2, ab, the product of these two terms, with a minus. If you pay attention, this expression here fits completely with this. A plus b, x plus 2. A2, x2. AB, 2x. B2, 2 to the 2 or 4. Because everything matches between this expression and this identity, so the answer is a to the 3, x to the 3, plus b to the 3, b is 2, 2 to the 3, which is 8. So the answer is x to the 3 plus 8. Of course, it's not easy to remember this identity, but sometimes you need these special identity, these special product formulas in courses like calculus. And for simplifying expressions, it's really helpful to know these type of relations. Look at the next example, which seems really complicated. But if you pay attention, if we consider this as a and if you consider this as b, so here we have a plus b. In the next bracket, you can see that this is exactly a to the 2. This is raised to the power of 2, as you can see. This power 2 can be outside or inside. Then, if you pay attention, this last term here is b to the 2. But what about that middle term, this negative 1? We have this negative. We have basically this negative. So this negative should be here. But why it is 1? It should be the product of these two, a times b. Let's see what is a times b here. So a is cube root of 2 plus radical 3. b is cube root of 2 minus radical 3. The product is cube root of a plus b times a minus b. If we multiply 2 plus radical 3 by 2 minus radical 3, what is the answer of this? If we multiply these brackets by each other, what is the answer? A plus b times a minus b. If you remember the identity that we started the video with that identity, with that formula, a plus b times a minus b is a to the 2 minus b to the 2. So the answer of this is 2 to the 2 minus radical 3 to the 2. 2 to the 2 is 4, radical 3 to the 2 is 3, 4 minus 3 is exactly 1. So this is cube root of 1, and cube root of 1 is 1. And if we pay attention, we have a 1 here with a negative because the formula has a negative. So this means that this middle term matches with the formula. So everything is ready for us here. So we have a plus b times a2 minus ab. So this middle term is exactly ab, and the last term is b to the 2. And because everything fits with the formula, so the answer is a to the 3. So the answer is cube root of 2 plus radical 3 to the power of 3 plus cube root of 2 minus radical 3 to the power of 3. The power 3 and the cube root cancels, the power 3 and cube root cancels, then we have 2 plus radical 3 plus 2 minus radical 3. Radical 3 and radical 3 cancels, 2 plus 2 is 4. So the answer of multiplying this expression by this expression is 4. Here I want to show you some applications of the formulas that we have learned for rationalizing complicated expressions. Look at this example. 1 over cube root of 2 minus 1. As you know, rationalizing an expression involving radical means that get rid of the radical. Here in this example, we want to get rid of the radical. We want to eliminate radical from denominator. The problem is that it's cube root 2 minus 1. So this is not an easy example. This is not elementary example. This is advanced example. How we can get rid of this cube root here? Here we need to remember this special formula. A minus b times by a to the 2 plus ab plus b to the 2 is a to the 3 minus b to the 3. If you attention, this formula is similar to the formula that we had in the previous example, but in that formula here was plus, and because here was a to the 3 plus b to the 3, if you remember, it was equal to a plus b times a2 minus ab plus b to the 2. But as you can see here, we have a minus b, we have this but with a minus. So the formula that we need here is the minus one. We need a minus b times a2 plus ab plus b2 is a to the 3 minus b to the 3. And if it was plus, we can use the other formula. Now let's focus on this example. We have 1 over a minus b. To get rid of the cube root, we have to multiply the numerator and the denominator of this expression by this. Because if we multiply a minus b by this expression, the answer would be a to the 3, b to the 3. If we have a power 3 for this cube root, the power 3 and cube root cancels. That's the reason we are going to multiply the numerator and the denominator by this big bracket. A to the 2, what is a? A is this. So cube root of 2 to the 2, which you can write cube root of 2 to the 2 would be cube root of 4. But let's write it cube root of 2 to the 2 plus ab, a times b. Attention, b is only 1. The minus is for formula. A times b is only cube root of 2 times 1, which is cube root of 2. So plus cube root of 2 plus b to the 2, b is 1. And we multiply the denominator by same thing, cube root of 2 to the 2. You can put the 2 outside or inside, doesn't matter, plus cube root of 2 plus 1. Now attention, here we have a minus b and we multiply by a2, ab, b2. The answer is a to the 3 minus b to the 3. So when we multiply the denominator by the denominator, we have a to the 3 cube root of 2 to the 3 minus 1 to the 3. And for numerator, 1 times by this bracket is this bracket, and cube root of 2 to the 2 is 4, cube root of 2 plus 1. For denominator, cube root of 2 to the 3 is 2, because the power 3 and with cube root cancels. So 2 minus 1 is 1. So denominator is 1, and when denominator is 1, you don't need to write the denominator. So what is the final answer of this question? Cube root of 4 plus cube root of 2 plus 1. As you can see, we rationalize this expression, which means that we don't have any more denominator with a radical, with cube root. Now look at this example. Rationalize numerator. Maybe you ask yourself, why we have to rationalize numerator? Usually we rationalize the denominator because we want to eliminate radical from denominator. But here, we want to eliminate the radical, the cube root from numerator. And attention, expressions like this appear in the calculus for finding limits or finding derivative of a function using the limits. So it's good to know this technique. It's very important. Rationalize numerator. We want to eliminate the radical from numerator. If you attention, here again we have an expression minus another expression and we have a cube root. To eliminate the radical from numerator, remember this identity. A minus b times a2 ab b2 is equal a3 minus b3. So if we want to use this relation to eliminate the radical, here we have a minus b. We have to multiply the numerator and denominator by this part, a2, ab, b2. What is a to the 2? The a to the 2 is cube root of 8 plus h. Cube root of 8 plus h to the power of 2. You can put the power of 2 for all the cube root, or you can just put the power for 8 plus h. So let's write it this way, plus ab. A is this radical, b is 2. So 2 times cube root of 8 plus h, and finally b to the 2, which is 4. And we have to multiply the denominator exactly by same expression. So cube root of 8 plus h to the power of 2 2 cube root of 8 plus h plus 4. Now let's multiply numerator by numerator, denominator by denominator. If you pay attention, numerator is a minus b times a2, ab, b2. So for multiplying numerator, we use this identity, and when we have a to the 3 minus b to the 3. So numerator is cube root of 8 plus h to the power of 3 minus 2 to the 3. Let's simplify the numerator. Cube root of 8 plus h to the 3. The power 3 with cube root cancel, and we have 8 plus h. So numerator is 8 plus h. 2 to the 3 is 8 also. So minus 8. 8 with 8 cancels. So numerator is only h at the end. So the answer of multiplying this by this is only h. All over in the denominator we have h. Don't forget we have h times by this. Times by cube root of 8 plus h to the power of 2 plus 2 cube root of 8 plus h plus 4. And now attention. The h from numerator with h from denominator cancels, and the final answer is 1 over cube root of 8 plus h to the power of 2 plus 2 cube root of 8 plus h plus 4. And as you can see, the numerator is rationalized, which means that in numerator we don't have any more the radical. I know it's interesting because we try to simplify this, but now the expression, the final answer is more complicated. But in calculus you will see that there is a good reason that we want to eliminate radical from numerator. I hope by watching this video you have learned how to use formulas, special product formulas for simplifying expressions. I try to show you different applications of these formulas. If this video was helpful for you, please subscribe to my channel and see you in the next videos.